Alright, welcome to your video lesson for section 8.3 and 8.4. We will be talking about the angle sum theorems that are involved with polygons. So first off, we know that a polygon comes from the Greek prefix of poly, which means many, and gon, which means sides. So we say polygon is a closed plane figure. You have to have at least 3 sides, so the smallest polygon in terms of numbers of sides you can have is a triangle, and then from there you have all sorts of different shapes. Now we say that a polygon is regular if you have all angles congruent, which means equiangular, and if you have all the sides congruent, which is equilateral. So looking at the examples here, are these polygons regular? Well, right away on the first one, I notice that these two sides here are not the same length as the rest of the sides. They all have to be congruent. So for this one, we are going to say it's not regular. For this one here, we notice that all 5 sides are congruent. And if you recognize the shape, you know it is a pentagon. So therefore, yes, we know that it is regular. Our third shape we see is a trapezoid. Now, the trapezoid is not a formal polygon for several reasons. First off, the only sides we know that are congruent are these 2 sides. And we don't necessarily know if this side is congruent to those, but we know for a fact that these 2 sides are never equal in a trapezoid. So therefore, it is not a regular polygon. Last but not least, we have ourselves a beautiful equilateral triangle. All the sides are congruent, all the angles are congruent, therefore we say that it is regular. Now, there are 2 types of polygons you can have. You can have what are called convex polygons. A convex polygon has no dents with points outside. So what we mean by a dent is we say, okay, the shape does not cave inward into the actual solid, or sorry, not the solid, the figure. Another way of kind of showing it is saying, hey, if I draw a point anywhere inside of my shape, I should be able to draw a straight line to any other point inside of the shape without leaving the shape. So I could connect a point from here to anywhere in the shape. I don't ever leave the shape trying to connect a straight line to those points. Now with a concave polygon, it has at least 1 dent with points outside of your polygon. So one acronym, or whatever it's called, the mnemonic that I like to use to remember is that a concave polygon has a little cave where a bear likes to sleep. So right here, there's a cave for the bear to sleep in. Right here is another cave. And for this shape in particular, there are 5 caves for the bear to sleep in. Another way to show this, which was what I was using earlier, if I place a point here, I cannot draw a straight line to every single point in the shape without leaving the shape. Right here, I would break that rule. Therefore, the shape is not convex, it is concave. So take a second, go ahead and try to classify these 4 shapes as either concave or convex. So right here on our first one, there's no cave for our bear to sleep in, so we say that this is convex. Right here on this second one, we see that there is a dent, which is this shaded region here. This is our little cave, so therefore this is concave. On our third figure here, I have 4 little caves, 4 little sections. Now, if you're having trouble kind of seeing that as a cave, just again remember that if I place a point here, I cannot draw a straight line to that other point without the line leaving the shape. So instantly we say that this is also concave. Now this one here we have is our pentagon. Again, there are no dents in the shape at all, so we can say that this is convex. Now right over here on our beautiful chart, we have the root words. Again, since Euclid was a Greek mathematician, most of our prefixes are in Greek. So tri, you should know, is 3. Quad is 4. Pent is 5. Now, in case you're curious, a penthouse is actually considered the highest level of a hotel room. Well, think about it, it's a 5-star. That's why it's called a penthouse. Then you have hex, which is 6. Hept, 7. Octagon, we have 8. Non doesn't mean no, like it does in the Latin prefix. Non, as a number prefix, means 9. And then dec, kind of like in the word decimal, that means 10, base 10. Why can't I write 10? There we go. Now I'm skipping 11 because 11 doesn't work out nicely with numbers. But when you see dodec, do means 2, dec means 10. So you would do 2 plus 10, which means 12. Now n, at this point, I can make it whatever I want. And what I mean by that is, at this point, I don't want to memorize every single Greek prefix. I don't have the time to teach you them all, nor do I know them all. The best way of looking at this is saying, hey, since I'm going to use English numbers in this case, if I want to talk about a 50-sided polygon, I could say a 50gon. I could say a 700gon. I could say whatever number that's greater than the ones we've listed. So going back to here, a triangle has 3 sides. Then we have a quadrilateral, which has 4 sides. Then we go into a pentagon, and then 6 sides hexagon, 7 sides heptagon, 8 sides octagon, 9 sides nonagon, 10 sides decagon, and then our 12-sided figure, dodecagon. Now that's not to be confused with a dodecahedron, as some of you might be thinking. A dodecahedron is a 12-sided solid. We're talking about 12 sides of a polygon. We're not talking about 3-dimensional shapes, just 2 dimensions. So then, of course, what we do is I want to talk about an n-sided shape. I replace the a with a hyphen, so it becomes an n-gon. So again, going back to, if I want to say a 20-sided shape, I can say a 20gon. Kind of lazy, but it's kind of conventional too. Super easy. Now, based on the rest of our notes, I'm going to make a second video so that I don't have to rush this. But go ahead and pause the video if you need to, go back, copy anything else that you need, and then just stay tuned for part 2.